Today I'm going to show you how to do a Wilcoxon test. Before we get started, there are a few things we should note. First, we want to find how many variables are in our problem. Next, we'll need to identify which variables are dependent and which are independent. Next, we'll want to look at our dependent variable and determine if the scale of measurement is interval or ratio. If it is interval ratio, then we'll need to see if there are two categories. Finally, we will need to determine whether or not our data is normally distributed. If it is not normally distributed, we may continue doing a Wilcoxon test. However, if it is normally distributed, it would be a different test known as a related t-test. So for now, check to see if your information is normally distributed or not. For our test, we are looking at 10 dolphins who were on a workout routine. We want to find out if this activity has increased the pounds of fish they eat per day. We will weigh the pounds of fish consumed by the dolphins before they started their workout routine. And then, after the routine has been implemented, we will measure the pounds of fish consumed. So we'll have a before and an after set of data, and those will be our two categories. So now we have our data set. We have the pounds of fish that the dolphins consumed before they started their workout routine, and then we have the pounds of fish that they would consume after they started the workout routine. So since these are related samples, and they aren't quite normally distributed, and we can tell because on the before data set, we have a larger number at 40 and a small number at 5, and our middle numbers are kind of spread out. For our after set, we have the highest number at 38 with the lowest number only at 11, and our data set is more concentrated in the 20s. So these aren't quite related, and they aren't quite normal, and we'll be able to do a Wilcoxon test. So our first step is finding the differences from the before data to the after. Even if it's a negative number, we'll want to record that because it's going to be important for the next step. So now we have our differences. Some of them are negative numbers and some of them are positive numbers. What we're going to do now is rank them in order. However, we're going to do a separate ranking for negatives and a separate ranking for positive numbers. What do I mean by ranking them? I mean put them in order from smallest to largest, numbering them, and I'll show you how to do that. As you can see here, I did the negative rankings in red, and I did the positive rankings in blue. And the way we do it is we start at the smallest number, and we count up to the largest number. Here we see that we have 1, 2, 6, and 10. So I rank them in order, and that's 1 for number 1, 2 for rank number 2, 6 is rank number 3, and 10 is the largest number out of all of the positive differences. So that's rank number 4. For the negative set of data, I started at -8 because that is the smallest number in this set of differences. So that is ranked number 1. I have -7 at number 2, -6 at number 3 with -5 at number 4, -4 at number 5, and -1 is going to be our largest number. The next step is adding up the ranks. So we're going to have a separate adding for each one. So keep your negative sets together and your positive ranks together in order to go to the next step of the Wilcoxon test. Now let's add them together. I simply took the numbers at the bottom that we have already ranked and put them in their corresponding sum of ranks, the positives and the negatives. For a total of 10 for the positive sum of ranks and 21 for the negative sum of ranks. So our next step is to find the t-statistic, which is going to be taking the smaller number out of the sum of ranks, which here is our positive sum of ranks at only 10. So we're going to use that number and search our table to find the t-statistic. Now let's look at our Wilcoxon table. The information we will need in order to find our critical value from our table is our sample size, which is 10 dolphins, our significance level, which is 0.05. That's a commonly used significance level, and it will make it easy for us to find our critical value. And this is going to be a two-tailed test. So now we know our critical value is 8, and we still have our t-statistic from earlier, which was 10. So now we have to compare these two. 10 is greater than 8. And what this means is that if our critical value is greater than our t-statistic, we fail to reject. But if the critical value is less than our t-statistic, we do reject. So here, our critical value is less than our t-statistic, so we will reject our hypothesis. There's not enough evidence to prove that dolphins are eating more fish after their workout routine than they were eating before. And that is how you do a Wilcoxon test. Thanks for watching.